Hey guys, I've been working on a pathfinding algorithm in Freepascal, and I've reached a point where I can share some of it with you. So right now you're looking at a grid that's been drawn using some Freepascal constants created with my other program, Raster Master here. Let me bring that in front. And basically, this program generates the constants, and we can use the put image to display them. So that's what makes up these little bitmap images if you're wondering how they're getting here. I'll go through the code and show you that later, but just in case you're wondering how I'm able to show simple images, it's very easy. Uh, but first, let me demonstrate how far I've gotten with the algorithm. So pathfinding algorithms, uh, there's a lot of info on the internet, and it can take some time to get wrap your head around it. And it's literally taking me years to even get something this simple. But I'm not that bright when it comes to this kind of stuff, so it took me a while. There's lots of YouTube videos. So they all have their way of explaining things. Uh, I try to go for generally the simplest way to explain something, and I think I got something really simple here. I'll release the code. It'll be on GitHub, but I'll kind of go through the code right now. Anyway, the best thing to do is just show how it works. So I'm going to step through. I'm going to be hitting the Enter key, and it'll be going through an iteration of uh, basically expanding the path uh, in order to find uh, this red character here we're calling our monster. This is our player, and let's start. So I'm hitting enter, and our arrows are being drawn, expanding outwards. So if we keep doing this, now if the algorithm would perform much faster if I didn't press enter, but it would all just appear instantly, so you wouldn't see how it's expanding out. The object here is to try and locate our our monster here. So right now, uh, the player doesn't know where the monster is, and this algorithm doesn't necessarily knows when it finds it, but we'll get a visual cue when we get close, and I'll show you. So we just keep hitting enter here, and you can see that it's expanding outwards. And we could add additional walls and other obstacles, but again, I'm trying to keep this simple. So it's going around the wall at this point, and you can see it's expanding outwards, but when it passes by the wall, it starts heading towards the monster there. That's our red image. And basically, when it makes contact with the cell that the monster's in, basically we've just solved our path. And these arrows, if we flip them the other direction, so the down arrows, if we flip them to go up, and the right arrows, if we flip them to go left, so every arrow we encounter, we invert the direction. It gives us our path. So if we follow this, if you can see the mouse, and what I'll do here is I'll take a screenshot. Let's just do this, and this way I can draw over. So now, if we just follow this arrow here, it points down, but if we change the direction, up, up, down, down, and left. So this gives us our direction. So if we were using this in a game, let's say a Pac-Man trying to locate, sorry, yeah, a Pac-Man, the ghost trying to locate the player. This would be something that we can use. This would give us uh, the location where the player is from where the ghost is. So if, let's say this was Pinky and this was Pac-Man. Uh, if we wanted the ghost to be smart, we could employ this algorithm and it would know that it would have to go in this direction around to find the Pac-Man. So that's one use for it. But pathfinding algorithms have lots of uses. And um, for my games, I'm going to try and do a few games. I think I've reached a point where I can modify this slightly and make it useful. So in a future video, I'll show that in a simple game. But I think that's as far as I'm going to go in terms of my pathfinding skills. There's a lot more complex things out there, and if you're interested in that, you can find it. But right now, I'm just going to step over through the code and and show you what I've done. So again, this is in Freepascal, but it should compile also with Turbo Pascal, and it should be easily modified. It can be easily modified to work with Lazarus and Freepascal for Windows and all that. So these are the constants I'm importing. Again, these have been exported from Master here. So this is the wall, and we export that by going here and Free Pascal. And this is all the different shapes, all the arrows and the monster and the player. And let me move that away. I'll bring in one of these so you can actually see what it does. So let's pick the player. So this is just an array of constants, but when you use the put image command, let's go down here. Okay, so this is the procedure that draws the grid, and it checks what's inside each cell, and if it's empty, it draws an empty square using the put image constant called empty. And let's go down here where we have the player. So if it finds the player is there, it uses the player constant. And that's how we basically draw our grid of items. So each time we update our grid, we draw it using the draw grid procedure. So it cycles through all the cells, and that's what you see when I'm hitting enter. We have a clear grid here, and this is how we place objects. So I have a place monster where I specified the coordinates, and in that grid cell, it puts the constant monster in there. And the same thing with the player and the wall. Everything else, um, we're using this procedure here called place direction shape, and I've shortened it to D or shape. And we're just adding this into our grid and also our queue. So if we go up here, I have an object that created a simple queue, and each time we place an arrow in there, we're adding into this queue as well. And queues can be used for a number of things. I've used it in my flood fill algorithm in the previous video. Uh, I've I've modified that to work here, and I've changed one thing. I added a pop first procedure. So normally we were doing last in, first out. Um, so the last item that was added to the array, that was the first item that was popped out. In this process, we're popping out the first item from the array. So we're adding things to the end of the array and then we're popping them from the first. So let's go take a look at that. Okay. So when we do a push, that means we're adding to the array. So we increase our counter and then we add it to our list here. And when we do a pop, it removes it from the last uh, element in the array. When we do a pop first, though, it removes it from the first. So it removes it from the first here, and we just bring everything that's in second or third down one spot. So everything moves up ahead. So that's what this loop does here. This returns our count, how many items we have in the queue. And basically the main logic is right here. So all these commands were just placing things on our grid. And what we're doing here is we have a little while do loop, and it keeps going until the count is 0. So we're doing while count not equals 0. It's waiting for me to hit enter. If I hit Q, it'll exit, but it performs a Q pop first, which means it's removing it from the first element in the array, and then passing, passing it on to this place dr8. So, and this is actually initially I had 8 directions I was drawing. That's why I gave it a name dr8. So instead of just going right down, left up, I'm going right up, left down, right down, left up. Um, Multiple directions, and I could just uncomment this and you can see I don't think I need this, but it kind of gives an interesting view. I might need to do a little bit more testing, but let's just see how that looks right now since I brought it up anyway. So you can see now there's more arrows, and we can cycle through this again. And let's see if this gives a different result. So now, yeah, it actually gives a better result. So I didn't actually reach this point before where I even tested this, but let me snip this out again. And this actually works. Okay, let's cut the whole thing. All right, so if we repeat the same logic again as before, the down arrow becomes up, and this is pointing right down, so we're gonna go left up. And we're going to reach here. This is pointing right up. We're going to go left down. And again, left down. And we reached our player. So this actually finds a more efficient path. Well, I wasn't really planning on it, but I'll do some more testing, but that looks like what it's doing. Anyway, that's it for this video. I will post the code on GitHub and you can play around with it.